grandfather ate a full bowl of white rice every single day of his life and never once developed diabetes. But today, millions of people are being diagnosed with type 2 diabetes, and doctors are blaming the exact same rice. So what changed? The answer will completely reshape how you think about food, your body, and the hidden forces quietly destroying your blood sugar. Starting right now. Picture your grandfather. Every morning, he sat down to a plate of white rice. Every afternoon, white rice again. Every evening, the same bowl, the same grain, the same staple that fed his family for generations. He lived into his 80s. Strong. Sharp. Never once diagnosed with diabetes. Now fast forward to today. Millions of people around the world are developing type 2 diabetes at alarming rates. Scientists are pointing fingers at white rice. But your grandfather ate more of it. So what is actually going on here? Type 2 diabetes is one of the fastest growing diseases on the planet. According to the World Health Organization, over 422 million people currently live with diabetes worldwide. That number has nearly quadrupled since 1980. In countries like India, Pakistan, Bangladesh, and China, where rice has been eaten for thousands of years, diabetes rates are now skyrocketing. Scientists and doctors began asking a very important question. If rice has always been part of these cultures, why is diabetes only exploding now? The answer takes us deep inside the human body. To understand the paradox, we first need to understand what white rice actually does inside your body. When you eat white rice, your digestive system breaks it down extremely fast. The starch converts to glucose almost immediately. That glucose floods into your bloodstream in a sudden wave. Your pancreas detects the spike and releases a hormone called insulin to bring those sugar levels back down. This process happens with every meal. The speed of that spike is measured by something called the glycemic index. White rice scores very high on that scale. The glycemic index, or GI, is a scientific scale from 0 to 100. Pure glucose sits at 100. Foods with a high GI cause rapid blood sugar spikes. White rice scores between 64 and 72, placing it firmly in the high GI category. For comparison, brown rice scores around 50. Whole grain bread scores around 51. When a high GI food enters your bloodstream repeatedly, day after day, your insulin system begins working overtime. Over years and decades, this relentless pressure on your pancreas slowly breaks down your body's ability to regulate sugar. A landmark study conducted by researchers at Harvard University tracked over 352,000 people across 4 countries over periods ranging from 4 to 22 years. The findings were striking. People who ate 3 to 4 servings of white rice every single day were 1.5 times more likely to develop type 2 diabetes compared to those who ate the least amount. Even more alarming, for every additional large bowl of white rice a person ate each day, their risk of developing diabetes increased by 10%. These are not small numbers. But here is where the mystery deepens. These same studies show that in rural China, decades ago, people ate rice as the center of almost every meal, and diabetes was remarkably rare. Traditional Japanese communities consumed rice daily for centuries without widespread blood sugar disease. Our own grandparents and great-grandparents built entire lives around this grain. Yet they remained healthy. The rice did not change. The science did not change. Something else changed. Something far more powerful than the grain sitting in the bowl. We are going to find out exactly what. To understand why our grandparents stayed healthy, we need to travel back in time. 50 to 70 years ago, daily life looked completely different. There were no desk jobs that lasted 8 to 10 hours without movement. There were no television marathons or endless hours on smartphones. Most people woke early, worked physically demanding jobs, farming, construction, manual trades, and walked everywhere. Research shows that traditional rural populations in Asia averaged over 12,000 steps daily. That level of physical activity dramatically changes how the body processes glucose, even from high GI foods like white rice. Physical activity is one of the most powerful blood sugar regulators the human body possesses. When your muscles are actively working, they absorb glucose directly from the bloodstream, completely independent of insulin. This means that a physically active person can eat a high GI meal and their muscles will pull the excess sugar out of the blood before it ever becomes dangerous. Our grandparents were essentially burning off glucose constantly through movement. Their bodies never had to store dangerous levels of blood sugar. Physical labor was their invisible medicine, taken 3 times a day, every single day. Portion size is another enormous piece of the puzzle that modern science is only beginning to fully appreciate. When our grandparents ate rice, they ate it from small clay or ceramic bowls. A typical serving was 1 cup of cooked rice, sometimes less. Today, restaurant portions of rice routinely exceed 3 or 4 cups in a single meal. Studies show that the amount of carbohydrates consumed in one sitting directly determines the height of your blood sugar spike. More rice in one meal means a higher, longer, more damaging glucose surge through your bloodstream. What our grandparents ate with their rice matters just as much as the rice itself. Traditional meals were built around rice as a supporting actor, not the star. A typical grandmother's plate included a small portion of rice surrounded by fiber-rich vegetables, legumes like lentils or beans, and fermented foods. A scientific study published in medical research journals proved that when beans are eaten alongside rice, the blood glucose response drops significantly compared to eating rice alone. Fiber slows digestion. Slower digestion means a slower, gentler glucose release, far less damaging to the insulin system over time. Now compare that traditional plate to what millions of people eat today. White rice paired with fried chicken. White rice beside sugary sauces. White rice washed down with a bottle of cola. Every single one of these food combinations accelerates the blood sugar spike. Sugary beverages alone can push the glycemic response beyond what the body can safely manage. Scientists studying modern Asian urban diets found that it was not the rise in rice consumption driving the diabetes explosion. It was the tripling of processed food, sugar-sweetened drinks, and animal fat consumed alongside it. There is one more hidden factor that scientists call metabolic memory. When the body is exposed to blood sugar spikes repeatedly over years, the pancreatic cells responsible for producing insulin slowly begin to burn out. This process is gradual, silent, and almost invisible until it is too late. Our grandparents never gave their pancreas this kind of repeated stress, because movement, fiber, and small portions prevented large spikes from ever occurring. But today, a generation of people has spent decades overloading their insulin systems without realizing it. The damage builds silently, like rust forming inside a pipe. Let us go deeper into the science. Inside every grain of white rice lives a powerful carbohydrate called starch. Starch is made of 2 molecules, amylose and amylopectin. White rice contains roughly 20% amylose and 80% amylopectin. Amylopectin is the dangerous one. It has a branched, tree-like structure that your digestive enzymes can attack from many directions simultaneously. This means it breaks down extraordinarily fast. The result is a rapid, powerful surge of glucose entering your blood, faster than almost any other common food. Your body must react with speed or face serious consequences. When that glucose wave enters your bloodstream, your pancreas triggers an emergency response. Beta cells, specialized cells inside the pancreas, detect the rising blood sugar and immediately begin secreting insulin. Insulin acts like a key, unlocking your body's cells so glucose can enter and be used for energy. In a healthy person, this system works perfectly. But when this emergency response is triggered multiple times a day, every single day, for decades, the beta cells become fatigued. They begin producing less insulin. Slowly, the entire regulation system starts breaking down. This is the beginning of type 2 diabetes. As the insulin system weakens, the body develops something called insulin resistance. This is a condition where your cells stop responding properly to insulin signals. Even when insulin is present in the blood, the cell doors remain locked. Glucose cannot enter. It continues circulating in the bloodstream at dangerous levels. The pancreas responds by producing even more insulin to try to force the doors open. Eventually, the pancreas simply cannot keep up with the demand. Blood sugar levels stay permanently elevated. This is diagnosed as type 2 diabetes, and it develops slowly, silently over many years of repeated damage. Here is a critical fact that surprises most people. The risk of diabetes from white rice is not equal across all populations. Scientists studying over 132,000 participants from 21 countries discovered significant geographic differences. People in South Asia, India, Pakistan, Bangladesh, Sri Lanka face up to 65% higher risk of developing type 2 diabetes from high white rice consumption compared to those with low intake. This is partly due to genetic differences in insulin secretion capacity. South Asian populations have smaller pancreatic beta cell reserves, making them more vulnerable to repeated blood sugar overloads. Brown rice contains the same starch as white rice, but it retains its outer bran layer. That bran layer is packed with dietary fiber, vitamins, and minerals that are completely stripped away during the milling process that creates white rice. Fiber is a game changer. It physically slows the movement of food through your digestive system. It forms a protective barrier around starch molecules, forcing your digestive enzymes to work much harder and much more slowly. The glucose release becomes gradual instead of explosive. Blood sugar rises gently rather than spiking dangerously. Brown rice scores around 50 on the glycemic index, significantly lower than white rice. Scientists at Harvard calculated that replacing just 50 grams per day, roughly 1/3 of a single serving, of white rice with brown rice reduces the risk of developing type 2 diabetes by 16%. If that same small amount is replaced with other whole grains such as oats, barley, or whole wheat, the risk reduction jumps to 36%. These are not tiny improvements. These numbers represent millions of lives that could be protected through a single, simple dietary shift. The science is clear. The difference between white and brown rice at a biological level is enormous. Over the past 2 decades, scientists across the globe have been conducting some of the largest and most rigorous studies ever performed on diet and diabetes risk. The PURE study, Prospective Urban-Rural Epidemiology, is one of the most ambitious nutritional research projects in human history. It tracked over 130,000 people across 21 countries on 5 continents for more than a decade. Researchers monitored exactly what participants ate and followed their health outcomes over time. The goal was to finally answer, with real-world data, how white rice consumption connects to diabetes development across different cultures and genetic backgrounds. The PURE study confirmed what earlier research suggested, but added crucial new layers of understanding. High white rice consumption, defined as 450 grams or more per day, was associated with a 20% increased risk of developing diabetes across the full study population. But the effects varied dramatically by region. In South Asia, the risk increased by 61% for high consumers versus low consumers. In China, however, the same high rice consumption showed almost no significant effect on diabetes risk. This regional difference opened an entirely new door of scientific investigation that researchers are still exploring today. Why was China protected while South Asia was not? Scientists investigated the total dietary patterns of both populations. In traditional Chinese communities, rice was consumed alongside large quantities of vegetables, tofu, and minimal sugar. The overall diet quality remained high even as rice intake was high. In South Asian communities studied, rice was increasingly paired with refined flour breads, fried foods, and sweet beverages. Researchers concluded that it was the overall dietary environment, not rice in isolation, that determined diabetes risk. Rice is a vehicle. What surrounds it in the meal determines where that vehicle takes your blood sugar. Researchers also began investigating the role of cooking and cooling in altering rice's glycemic impact. A remarkable discovery emerged from food science laboratories. When white rice is cooked and then cooled in a refrigerator for 12 hours before being reheated and eaten, its glycemic index drops significantly. The cooling process converts some of the digestible starch into what scientists call resistant starch, a form that behaves more like dietary fiber than like sugar in your digestive system. Resistant starch passes through the small intestine without spiking blood sugar and instead feeds beneficial gut bacteria. Japanese researchers took this discovery further. They conducted clinical trials testing glutinous brown rice, a variety that combines the fiber benefits of brown rice with a texture that is more palatable for daily eating. Participants with type 2 diabetes who ate glutinous brown rice twice a day for 8 weeks showed measurable improvements in blood sugar control compared to those who continued eating white rice. Their HbA1c levels, a key marker of long-term blood sugar control, showed statistically significant reductions. This research demonstrated that the type of rice consumed is a genuinely powerful medical variable in diabetes management. Scientists also studied the powerful effect of meal sequencing, the order in which you eat different foods at the same meal. A clinical study proved that eating vegetables first, then protein, and eating rice or carbohydrates last significantly reduced post-meal blood glucose spikes compared to eating rice first. When fiber and protein enter the digestive system before starch, they physically slow the absorption of glucose. The blood sugar curve becomes flatter, lower, and more controlled. This research suggests that the simplest intervention sometimes requires no change in the food itself, only in the order you eat it. So what does all of this science actually mean for you and your family? The message from researchers is both reassuring and empowering. White rice is not a poison. It does not need to be eliminated from your life or your culture. What the science demands is a smarter relationship with this ancient grain. The key variables are portion size, physical activity, the foods you pair with rice, the order you eat them, and the overall quality of your diet. Change these factors, and the same bowl of rice that harms a sedentary person can be safely enjoyed by an active one. The first and most powerful tool available to you costs nothing. Move your body after eating rice. Even a 10-minute walk taken within 30 minutes of finishing a rice-based meal has been shown in multiple clinical studies to significantly reduce the blood sugar spike that follows. Your muscles act as glucose sponges during movement. They pull sugar directly out of your bloodstream and convert it into energy. This mechanism works regardless of your age, fitness level, or genetics. A short walk after lunch is not just a cultural habit in many Asian traditions. It is now confirmed science. The second strategy is to rebuild the traditional plate. Your grandparents instinctively created blood sugar protective meals because that was simply how food was prepared. Start by filling half your plate with non-starchy vegetables before adding rice. Add a serving of legumes, lentils, chickpeas, black beans to every rice meal. These fiber-rich foods slow glucose absorption dramatically. Research shows that adding beans to a rice meal can reduce the glycemic response by up to 30%. This single habit, consistently practiced, creates the same protective environment your grandparents experienced without even knowing the science behind it. The third strategy is to consider switching entirely, or even partially, to lower GI rice varieties. Brown rice, red rice, wild rice, and black rice all contain significantly more fiber and nutrients than white rice. They digest more slowly and produce gentler blood sugar responses. If the texture or taste of brown rice is a barrier, try mixing it half white, half brown. Even this simple substitution lowers the meal's total glycemic impact measurably. And remember the cooling discovery. Cooking rice the night before and reheating it the next day genuinely changes its starch composition in your favor. Researchers are now developing the next generation of solutions for populations where white rice cannot realistically be replaced. Food scientists are engineering new rice varieties with naturally higher resistant starch content. Biofortification programs are developing rice strains that retain more fiber even after milling. Some research teams are exploring probiotic combinations that, when consumed regularly, improve the gut microbiome's ability to process high GI carbohydrates more safely. These innovations represent a future where the cultural and economic centrality of white rice in billions of lives does not have to conflict with the goal of preventing a global diabetes catastrophe. Your grandfather ate rice every day and never developed diabetes. Now you know exactly why. He moved constantly, ate small portions, filled his plate with vegetables and legumes, never drank sugar-sweetened beverages, and never sat still long enough for glucose to become his enemy. The rice was never the problem. The life built around the rice was his protection. That protection is not lost. It is simply waiting for you to reclaim it. Move after meals. Eat vegetables first. Reduce your portions. Choose whole grains when you can. The science of your grandparents is now the science of survival.